All right, how's everybody doing this morning? Pretty good? Okay. How many people actually get to use FP in their day job already? And how many people would like to use FP in their day job? So it's a pretty good mix, 50-50. So half of you are probably gonna be bored, and for that I apologize. Let's just jump right into the benefits of FP. I'd like about 2 people to maybe give me their favorite thing, just a sentence or 2 of their favorite thing about FP. Yes?
Easy to test.
Easy to test.
If it compiles, it's usually going to work.
If it compiles, it's usually going to work. Yep.
I can read it like English.
Say it once more.
I can read the FP code like English.
You can read the code like English. Okay, cool. Those are a lot of good benefits. And I forgot to click onto my clever slide before asking. The code's easier to reason about, right? That's kind of what you're getting at. You can actually read the code. It's easier to make decisions with. I've had the pleasure of working in a C++ code base for the last few months, and it's fascinating because by virtue of just walking through a graph of nodes in this class hierarchy, it starts making RPC calls and mutating the database, triggering other services in the stack to do things. And it's absolutely fascinating because the only way to understand what's happening is to run the code and try to debug the stack of 25 services, right? That gets exciting. I like that. Which kind of leads to this. There's fewer surprises. I don't have to guess as much, or I at least know when something might be calling out to go mutate its environment in some way. And all these things can lead to a decrease in defects, right? If we follow nice functional patterns, it becomes more clear where these things are going to happen, and we have fewer surprises, so we get fewer defects in our code, hopefully. And maybe all of that leads to a decrease in actual development time because we can reason about the code. Maybe we put a little more upfront design time in, but hopefully we're spending less time debugging in production, right? We don't have to debug 25 services just to figure out that, oh, I instantiated a class and that changed my database and broke a bunch of stuff. But basically it's better in every way. Right? That's the gist. That's why we're all at this awesome conference learning, right? So that's pretty much my talk. You can go back, articulate that list to management, and then you're going to be good to go. You can just start using FP. Except that isn't enough, or everybody would have raised their hand on my first question. And that's kind of what we're going to get into a little bit now. I want to start with some background, just to kind of context set for everybody. The company where all this transpired at was extremely friendly to new technologies. The CTO, very believed anything that could possibly make something better, we should try to introduce. Even beta technologies. The company was founded and built on a very beta stack, and that was just ingrained into the culture. Basically, he believed the worst thing you could do was not be aggressive, which kind of makes a big difference in a company's culture. So that kind of set the essence of who we were as a company. And this wasn't like 5 people. This is a company that grew through the course of these stories I'll be telling. We grew from a handful of engineers to hundreds of engineers. So it's a pretty high growth thing. And with that, I want to jump into Scala. Now, I want to warn everybody, especially the Scala fans, this is not a happy ending story. But it's okay. I think there's still some positive takeaways here. So a little bit of context on this initiative. This was one of the most clear functional languages we were trying to introduce, 4 functional concepts. We picked a project that was super important to the company. We had a relatively tight delivery deadline, and it was an excellent fit for FP. This had to do with maintaining some graph state in memory, and we needed immutability and all of these things that lined up really, really well with Scala. One of them was also that other pieces of the stack were on the JVM. Little background on the team. This was a incredibly strong team of engineers. Two of the people are probably some of the smartest engineers I've ever met. And then they had a number of less experienced engineers, but were all outstanding, really strong team. Everybody had some degree of familiarity with FP, but nobody actually had practical experience with Scala in production. They'd kind of messed with it at home, maybe done some projects in other functional languages, things like that. We had one really vocal supporter of Scala, just said this is the thing to do, this is what we have to do, and most of the rest of the team was relatively indifferent. They said, okay, we'll do that, we'll also just write Java or do something else, but they were willing to try. Again, this is such an important point. Nobody actually had hands-on experience with this in production. So the Scala supporter, he just jumped in, and he's like hardcore going all out Scala, right? He's like writing a DSL for this particular problem, and it was pretty awesome. The couple other people that were pretty well versed, they'd worked in Clojure. We had some people who'd done some things in OCaml, I'm not actually sure how to pronounce it, but they had some familiarity. They were just writing nice functional code. Functional in terms of FP patterns, but also functional in terms of it worked. It did what it was supposed to. And the junior devs on the team, they basically just wrote Java. They're all familiar with it. Most of them had Java jobs previously, so they're just writing Java. And we happened to take a picture of someone working on the code base, right? This is kind of what wound up happening. Everyone was writing different stuff. This was like a huge thing, and it was kind of amazing to watch this over the course of 6 months. It became frustrating, and I remember sitting in my office in Boulder talking to the major Scala proponent, and I was like, hey, this is what I'm hearing from the team, what's going on? And I started asking him some questions, and then finally he comes back and he's like, yeah, I have to admit, this like lack of consistency does make it a little bit difficult to reason about the code. Every time I go to debug a library, I'm digging in and I have to go learn like what are they doing so that I can follow and understand the code. So that was kind of like a interesting observation for me of, that's interesting. The other thing that I just was continually hearing about, and full disclosure, I did not actually code on this code base. My role in this was the head of architecture at the company, so had a much broader scope and picture. But I had these engineers, because this was critical, one of my daily jobs was checking in, making sure that they had what they need, that we were keeping progress. And this thing called SBT, kept coming up, and what they said is, the builds are so slow. This was also about 4 years ago, so I'm sure it's totally different now, but crazy slow builds, and there was something about different versions, libraries, you had to use SBT to get compatibility, and a whole bunch of these little nuanced details that were kind of interesting. And the bottom line was nobody seemed to like this tool, and I didn't know enough to really help other than say, okay, we can try to hire some people that maybe know, which is a point I'll kind of hit on at the end where that comes into play. The bigger item for us, though, is we were a company that is totally cloud-based. And we had a lot of systems on the back end. Some of these things would scale to many tens of thousands of instances. I think some of our bigger clusters would approach 100,000 instances up. So it's a very big distributed environment. And one of the things we thought was going to help was this JVM-based nature of this, but it just didn't fit into our infrastructure with the other pieces. It wasn't how anything else was actually architected. And this ended in some very, very serious pain and disagreement. Ultimately, this was, I think, maybe the only mandate from our CTO in the company, which was there was going to be no more Scala. That was the single mandate. I will never forget that meeting because in the 10 years I had been like working there and known him, I was floored. I'm like, wow, what went wrong with this? Scala got blamed, but it wasn't actually Scala's fault. It was a combination of us with Scala. And I apologize for the Scala people. I was trying to find something about concatenation, and when I searched on Stack Overflow, I found these 2 answers, and I didn't know which was the right one. Bad joke. Okay, so some takeaways from this. The bottom line was this was too flexible for our culture and our environment and the maturity level and the size of our company. It just was not a good match. The bigger thing, though, in this case, really, this is probably the thing to be blamed. We thought we picked a good project to do this on, right? The tech fit in perfectly. You probably couldn't find a better tech. But we picked a time-sensitive thing that was high risk, high demand. And probably that's not a smart choice to introduce a brand new thing at this scale, where we just say all things will be done in Scala on this project. The bigger issue that came out of this kind of spooked our management, which I was in management and got to sit in these meetings, right? Like, it spooked people. They're like, wait, these functional things, wait a minute, which was a really sad state of affairs to be in, right? That's not ideal. So here's a common question that we kind of started with, and we should start with, which is, how is FP better than the alternative? And very rarely do we find things that are a strictly better than situation, right? When you look holistically, there's not a lot of things you can say, oh, this is better in all situations for all problems and all environments. It's a little more nuanced than that. And one of the big things, my background is an economist, by the way. So one of the big things is that you can't really focus in on the benefits without also acknowledging the costs, right? Everything has an opportunity cost to it. And we didn't. We actually did not intentionally ignore these. What we did is misread all of the signs, right? And we kind of went the wrong way and misgauged what was actually going on. We thought that the flexibility was going to help. That was going to be a big boost. We thought that, JVM, we already have various Java flavors. We have other small installations of various JVM languages. This is going to be fine. This is going to work really well. But the tooling didn't match up with the rest of our infrastructure. The runtime environments, like Akka, just could not work in our environment. It wasn't designed for that. We thought just being able to write Java instead of having to go learn and write Scala was going to help. And instead, it just led to a very, very complicated code base that nobody wanted to work in anymore. Those things are maturity problems for us, right? That wasn't a language problem, that was us. One of the takeaways we actually had after all this kind of retroing the experience was, we should have followed Twitter Scala guidelines, and we should have just mandated this is what we do. And that was a thing that probably would have helped us avoid some of these issues if we had just found a nice opinionated guide to try. Also, we shouldn't have done this on a critical project. That was a massive mistake, which is exceedingly obvious in hindsight. But at the time was like, it's a perfect tech. You always use the perfect tech for the thing. So now let's rewind back even further. That was about 4 years ago. Let's go back to like 2010 and talk about our culture. Our code base was a massive Python code base on the back-end systems. Millions of lines of Python code. I don't actually have an exact line count on this, but it was very substantial. So there's this idea of Pythonic. Has anyone coded in Python? Lots and lots of people. So anyone who's done this professionally knows what Pythonic means, and it's completely trivial to identify Pythonic code. I could stand back here and look at someone in the back of the room coding, and I can just tell by looking at the flow of the code if it's not Pythonic for sure, right? It has a very structured feel to it. That was an important thing. Other huge thing with Python, there's one obvious way to do things, right? In Scala, they had infinite number of possible ways to do any task, but our culture was set up to where, oh, there's one obvious way to do things, and if you don't do it that way, there's like 20 engineers who are going to jump in and make sure that you know that you don't have to say for I in like length of a list, right? That's not how you do it in Python, and everybody knows that once someone's jumped you about it once. So there's one obvious way to do things. Python was, this idea of Pythonic, it was ingrained into the culture of the company. The other thing, as I mentioned, we were building big, big distributed systems. And this started to influence a number of things with the ways we developed. This code got deployed out, and then throughout the day it would automatically scale up and down. And I'm pretty sure the screen grabs I have, some of the biggest were just under 100,000, is like 90-some thousand instances of this code running at peak times, right? So these are big distributed systems, and they're all asynchronous, communicated via asynchronous channels, and is pretty interesting. With that kind of started making one of the guys in the audience, we wrote one of these major core systems, and we started realizing, wow, OOP is leading to a lot of defects that we're having to deal with. Oh, and my video's not working, despite having tested it. Probably implemented in C. Anyway, so, oh, perfect. That's why it's not working. That's okay. So it led to really, really hard to debug defects is the translation, right? So we had started porting pieces of the code to follow functional patterns. That was actually what had led us to start doing things like immutability and using objects purely as a data container. Oh, okay, that's... Let's see.
You have made your mistakes.
Oh.
But I have made
So we got that to come up now.
Wait, many. Actually,
That's programming and object-oriented programming, right? that was supposed to have came up when I said OOP and then that. Okay, so yeah, so we had started naturally writing functional code. All right, we started naturally writing functional code, right? We were following immutable data structures, and we were very careful about mutating state, started returning copies, and using objects purely as data containers, as you would records in other functional languages. Bugs in the object-oriented code, they could take like anywhere from a couple hours to weeks to trace down in production. Even though at this point, we had a very robust suite of automated testing, like it could take weeks at this scale, and it basically involved me dumping data into something like BigQuery or some other type of system that allowed me to run analytics over this and look for little patterns and tease it out. It was incredibly laborious and tedious. And that's what actually led us to start exploring functional languages and come to LambdaConf for the first time, was all these experiences. Now, about that same time, so this is back up to 2013 at this point, we had introduced Golang. And I know it's not a functional language, but it's instructive because it's still introducing a new programming language. And in this case, it happened almost by pure mistake. We had thrown together a prototype just to demonstrate this other pattern that we could use for doing some of these back-end processing jobs. And everybody kind of looked at this and they got crazy excited, and it just started spreading throughout the company. Suddenly everybody is rewriting all their stuff in Golang. It's like, what is actually going on here? It was new and it was exciting, and mostly it was incredibly premature. I don't remember exactly what release Go was at, but this is like early days, and It was amazing. And especially the fascinating part is no one was shipping stuff, right? Everybody's like busy rewriting all their stuff and nobody's actually delivering anything to production. That's a great spot to be in. No, we did eventually actually get these things shipped, but it was not trivial to do. So there's a couple takeaways I want to point out from our experience with Go. That lack of flexibility, we kind of learned, in our culture, this lack of flexibility really, really helps. We needed things to fit us that were very opinionated, that made it clear this is how you do it. And the other thing that we liked a lot is, in the case of Go, the tooling enforced the styling. With Python, the PEP8 standard it's the canonical way you format your code, and it's like super obvious, and that's what everyone follows. With Go, they just built this in, and everybody runs it, and it does it for you. That was a good fit for us. It gave us that Pythonic feel that we needed in order to fit our company and our culture. It's also limited in many ways. How many people have programmed in Go? Quite a few. Yeah, its type system is like the most advanced I've ever seen. Right? You either just copy paste all of your code or everything is an interface and it's like just absolutely phenomenal. So anyway. But that lack of flexibility helped us, and it led our engineers that were used to this structured way of doing things to start picking this up and running with it. It fit our culture really, really well. But one thing we really, really should have done was probably shipped one thing first. Just one thing would have paved the way, and we wouldn't have had this little lull while everybody's rewriting everything in Go. We wound up with, actually one of the infrastructure engineering guys is in the audience here, and we wound up with the infrastructure engineering team just floored trying to implement all these new, Go also doesn't have package management. Still, I think they have like 7 competing ideas, but we wound up trying to solve all of these problems. How are we going to do package management? How are we going to build this stuff? How do we deploy artifacts? How do we, right? All these problems that are now dumped onto our operations and infrastructure team's lap. Oh, you guys, we've rebuilt the whole stack. You just have to implement this way for us to run that stack in production. That wasn't really ideal. We basically wound up doing too much all at once. And this is like crazy risky to do this, right? We're just completely betting the farm on our ability to get this out and this language being stable. That was exceptionally risky. And it strained a lot of parts of our organization to do this. We wound up with endless war rooms trying to figure out how do we deploy this new critical product that's implemented in a new language we have no runtime support for. Those considerations were not taken into account when everyone got carried away and just jumped on. The essence of this was it was a really high-risk thing, but the language, the tooling fit the culture, and that's why it was able to start spreading. Which leads us to 2016 at a LambdaConf. How many people have programmed in Elm? How many people know that Elm's not a real functional language? I had to ask. I like Elm. Most of my functional code now I just do in Elm because it's nice. So as a bit of a joke, it's a nice language, and we knew that. That's part of why we said, Go spread like a wildfire through the org. Maybe this would actually be a good fit. This was one of the few things that was a very intentional and reasoned decision. And it was pushed by management, actually, on this. In full disclosure, that was me. I was the one who went to Nick, who's sitting over here. He was the guy who was the guinea pig. And I said, hey, Nick, I want you to go rewrite this thing in Elm and just try it. And he's like, but we have deadlines. I said, it's fine, just go do it. Just go give it a shot and tell me what you think. And he's like, okay, I'll do it. So Elm's super opinionated. It's very, very clear. Its tooling is amazing. Like it's it's really, really robust and powerful tooling. The compiler just walks you through building your code. Not to the level of like the dependent typed programming things, but it's pretty nice. And we wound up shipping this entire new product in a month, which is just crazy. This was a internal product, which I'll talk about, but we had 500 users that were in our engineering org immediately trying to use this stuff, and we did this top to bottom in a month. We'd been working on the previous version for months. We had estimated it was something like a 6-month project to implement this. We went and banged this thing out in a month. And one of the nice things, I remember I was standing in the kitchen at the office, and Nick comes in and is like, man, we got this thing re-implemented, and this bug we'd been chasing for 2 months in the other stack, it's like not there in this implementation, because with types, we were able to actually specify this behavior, and it's like, wow, okay, so we're eliminating bugs at that rate, and the overall defect rate in this thing just like bottomed out. Which for me, being in management, is like, wow, that's a really nice thing to hear. Not only did they not slow down at all, we delivered this thing in about 20% of the time, and we have like no critical bugs in this thing when it's released. That's phenomenal. So the next thing that is really awesome, has anyone ever participated in a major refactoring of a non-functional code base? Like a handful of people, and that was like a super smooth, easy experience, probably no bumps. Yeah, exactly, right? So it's just perfect. On time. And on time, and it was good. One of the awesome things with this, they did a complete re-architecting of this. It wasn't a rewrite. They just totally re-architected the flow of this app, and took them like 2 weeks to do this, and there were no major issues at all. They were able to just sit down, start working through pieces, which is pretty phenomenal if you're one of the lucky people who've got to do this in like a C code base or something. The big thing with this one, the product that we selected for this, it was an internal thing. It was super, super huge value add, something internally we'd been asking for like years and years, but it wasn't critical path. This was meant to be an experiment where we could take some risk and try something new. It was also isolated. It wasn't in the mainline normal thing. Instead, we wanted to say, let's see if this is actually a valuable thing that we can do. So some takeaways out of this project. Like Golang, it fit our culture. That opinionated nature of this just mapped in to how we thought and how we programmed and managed projects, and it fit us really well. So that was a huge aspect of this. The other thing, in this case, having a management champion was very important, because the competing idea was to use the same frameworks used for the actual customer-facing products, which were the development time that went into them was orders of magnitude different. I mean, years versus like weeks in the Elm code base to deliver comparable functionality. But that also meant it's kind of ruffling some feathers, and I got to go sit in some tense meetings and justify this. So in this case, it wound up being important because it was so against the grain. But the value of this was immediately proven. There was no way anybody could argue, oh, this was a bad idea, right? We shipped a new product, top to bottom, in a tiny, tiny fraction of the time, and had, relatively speaking, almost no defects, compared to our other systems. That was a pretty huge thing. But this isolated ancillary project was really, really important to all this, because it allowed me as a manager to kind of shield this and say, hey, I want to let this run its course. I want to see where it goes, and I want to see if this is a valuable thing we should be doing more of. Sadly, and this is the main takeaway out of this, so that was a success, and we were starting to get have people get interested, and there were discussions of, wow, should we port other things to this? This seems pretty powerful. But it's actually still in use, the system is, but it's probably going to wind up being replaced. And that's because all of the promoters have since moved on for a number of reasons. So my other favorite one, the little rascal who snuck in Haskell. This is actually one of the most brilliant ways to get a functional language starting to get picked up that I think I've hit. So basically we had this API, very, very critical system. Everything else is critically dependent upon it. And so what started happening is this engineer built out the API spec in Haskell. And all of a sudden people are actually using Haskell to talk about how this API should behave, the data models, expectations on how things are going to flow through the system. And by documenting these expected behaviors this way is kind of a clever way to get people to open up to this idea a little more broadly. It made experiments possible. What if we change this API structure? What if we adjust that a little bit? We could actually have well-reasoned conversations with this. And the biggest thing is it actually provided an extremely concrete documentation of this API and what was expected of its behaviors, which leads us to closure, which is ongoing success at the company. So the immutable data model was an excellent fit for this problem. It's a core piece that basically is all about having an immutable data model accessible to other systems. Unfortunately, as it turns out, immutable data models are totally unnatural in many other languages, right? Lots of things depend upon just mutating an object. And so that's something that they've had to deal with a little bit. And the way they've dealt with this is the team that wanted to use Clojure took it upon themselves. Say, we are going to build client libraries and implementations that provide a native feel. And that way, we don't have people saying, oh, this thing is polluting our ecosystem. And right, they looked at these other examples and they said, okay, we should try to make it natural and native feeling for people to use these. They also did not actually just pick a language to pick a language. This wound up with them prototyping this in a number of different systems, and it was just apparent that the Clojure implementation was the best out of all these things that were tried. That's a huge thing. And the bigger thing is they actually offered to work with the infrastructure group to try to support this and make sure that it would fit in. So some takeaways from our Clojure experience. Number one, this team, they're focused on providing value. Fascinating thing with this is actually a critical project to the company as well. Extremely critical project to all of these underlying things, but the team doesn't focus on the tech. They're not saying, oh, we're using this thing because it's the right thing. Say, no, we're building this system to provide this value, and that's their focus. And what that means is they're just hitting deadlines and they're having very few production issues as a result. That's how they communicate, it's how they focus. And they're not trying at this point to start evangelizing and spreading this in the company. They're just focused on proving we can build a critical system to the company that actually works and delivers value, and we'll make sure that we help support this. And the big thing is they actually worked with infrastructure and operations, right? Those people can be your worst enemies if you're choosing something that doesn't fit, or they can be your biggest supporters and help you make sure you have a good experience. So kind of a key thing, the language doesn't matter. It's hard to make that your core focus. We had all kinds of attempts for people to introduce their assorted favorite languages. I think Ruby was one of them. We had a massive contingent that said, oh, obviously we should get rid of Python and go to Ruby because it's Ruby. And that went exactly nowhere, right? You can't, it's hard to like get buy-in for somebody to do that. Those things, they just never worked. I don't think a single time did that work. Anytime we tried to do that, we focused on the tech and not on the value, it just didn't go anywhere for us. So some key takeaways from the overall talk. I suggest that you start with a small thing. And this may mean if you're already in a Java code base, maybe you can actually use Scala, be disciplined, use it in a small area, and start proving that there's value. That is probably the biggest thing, right? If you want management to buy in, show them that there's some serious value to what you're proposing and help them understand what that is. Demonstrate it fitting into your ecosystem, right? If you're a Python shop and now you're saying, hey, we're gonna like do JVM stuff like with Akka, and your operations people are going, what? That's not going to probably work so well. The other thing that we've learned is it is probably the best to pick a lower risk project just to make your first steps into this. Even though the biggest value maybe will come from these high risk things, the reality is you maybe need some learning time if you're going to introduce this with a new language. The other thing, if possible, find someone in management who's going to be willing to help you defend the decision. I don't actually know this is not a requirement, but it certainly can help, especially if you're proposing a bigger introduction or a bigger change. This is just general advice. Go slow, prove something out, get one thing actually released, and then you can try to go all in. But my suggestion would be to go slow, dip your toe in, prove that it works, make sure you have some understanding. And really, you're trying to learn first, right? So that when someone comes and is asking questions, how does this thing work? What's this going to do in this situation? You have some good answers to those questions. Befriend your operations and infrastructure people, right? They can really make for some serious pain if you alienate them. So help them implement this. This was one of the biggest things, was the closure team offered to help make sure that the build systems could support this, make sure that package management was correct. And this was a problem for us with the Scala groups, that we didn't have support for all those things, but were being demanded to implement this in addition to supporting 45 other teams of engineers. So that was a big thing that led to some conflict. Plan for hiring. Where this bit us on Scala was that the team doing this work was in Bozeman, Montana. And we wanted to hire a John DeGoes in Bozeman, Montana, and we couldn't find someone with that level of Scala that could come help the team figure this stuff out, that wanted to be in Bozeman when we needed them. And generally speaking, I'm not a fan of hiring for a specific tech, right? Because as soon as you change the tech, maybe you have a problem. But in this case, we needed, and we knew, hey, we need someone who's really good at this stuff, that wants to be co-located with the team and can help us ramp up and make sure this thing gets delivered. And we struggled to find that. We looked for, I think, 3 or 4 months. I think I interviewed 5 or 6 people a week, just trying to find that. And we just struggled like mad. The other thing, the most obvious thing, John kind of mentioned this a little bit ago, start using functional paradigms in the languages you're already using. Many languages have functional aspects that you can implement and work against. And the last thing, if you want this to spread and disseminate in your company, you need to become a promoter, right? You've got to make sure people see the benefits, and that means that you're going around and you're talking about the benefits, educating your teams, and offering to help. If you want this to be a thing that's going to spread, make it happen. You can't just say, we should obviously switch our 5 million line C code base to Haskell because that will solve all problems immediately. That's probably not going to work. Go make it happen. Prove some value, rewrite some pieces, and offer to help people on board. Do lunch and learns, whatever you need to. This was true, by the way, of all the new technologies we introduced. From unit testing to build systems, we had people that took ownership and said, I will make this happen. I will go sit with your team, and I will sit with you as many days as are needed to help you understand this and want to adopt this. And that was one of the biggest things. So I ran right up to the tail end of time, but if there's a question, I'll take it. Yep.
I have a comment and a question. The comment is, your story reminded me of something I came across when I was learning Java, which is Thompson's first rule of telescope making.
Thompson's first rule of telescope making? Okay, I have not.
I think, if I remember, it goes, it is faster to build a 4-inch telescope and then a 6-inch telescope than it is to build a 6-inch telescope.
Yep.
And that resonated with me. It made sense.
Yep, I like that.
And it's, you basically described some of the properties that I thought that was alluding to. And my question is, what was it about the OOP style of programming that was causing so many problems?
Mostly it was trying to understand. So the question is, what was it about object-oriented programming that was causing us so many challenges? And mostly it was time spent tracing through mutations. So just simply trying to understand where was an object state getting mutated, and it was just lots of little nuance in those details. We really needed for that system an immutable first type model. I don't know. I maybe have time for like one more question. Yep.
What do you do with, you talked about sending the functional programmers to evangelize other teams, but those people on the other teams might consider their tools and their object-oriented approach to be superior and have their own ways of doing things. And what do you do with that sort of resistance?
So the question is, what do you do with the teams that think that their approach is superior or better? That is a fascinating question. And I think that's where this kind of idea of really proving the value starts to come into play. I'm not a fan myself of the hard sale of saying this is how you have to do it and I'm right and you're wrong. Part of that is that I think by having discussions, we all get better. And so that's how I would approach it, is by having a discussion, and I would focus on demonstrating that this approach is better. That was actually how we started spreading some of the functional patterns, was because teams were looking at our team building one of the biggest and most complex systems we had, and said, why are these people's defect rates so low? We had, I don't want to say we had no production bugs, we absolutely did, but compared to most of the other groups, we had very, very, very few production bugs. And that was one of the things people just started coming to us then and asking. And sometimes it's from their manager saying, hey, look, you need to go have a conversation with this team and see if they can help you fix this thing. So we mostly did it by just setting an example. Kind of leadership by example was our approach. And frankly, being a salesperson, that was the other big thing to do this. So I should probably wrap it up now, I think. And yeah, thank you, everybody. I appreciate it.